Okay, you're welcome this evening. Sorry, I'm making this video in the night. So, um, we're going to be looking quickly at rates of reactions. Okay, and so we quickly look at the definition. What is rate of reaction? Rate of reaction talks about how fast a reaction takes place or how fast reactant turn into product. Okay, so when you talk about rate of reaction, you're talking about how fast does a reactant turn into what? Into product. Okay, so we consider the reaction here between zinc and H2SO4. You can see zinc reacting with H2SO4 to give us zinc SO4 plus hydrogen. Okay, now the rate at which the above reaction occur can be viewed in four ways. Okay, now first of all is that the rate of reaction can be based on consumption of zinc. Remember, zinc reacts with this to give us this and this. So rate of reaction can be based on this, it can be based on this, it can be based on this, and can also be based on this. Okay, so let's see. So if you are saying based on zinc, it means the amount of zinc used up all over the time taken, because the formula for rate of reaction is simply the amount of substance all over time taken. Okay, so let's see this. The rate of reaction based on the consumption of H2SO4. Okay, in this case we are considering H2SO4. Remember, zinc and H2SO4 are the products here, are the reactants here, while zinc sulfate and hydrogen are the products here. Okay, so the reactants are the ones that are going to be used up, but the products are the ones that are formed. Okay, so you can say that it is the amount of H2SO4 used up all over the time taken. Now you can see rate of reaction based on production of zinc sulfate. In this case, production, it is equal to the amount of zinc sulfate produced all over time taken. Then we see for hydrogen here, you can see that based on hydrogen, the amount of hydrogen produced all over time taken. So for the reactant, it is used up, but for the product side, it is produced. Okay, so any of the species of the reactant or products can be used to determine the rate. Okay, the rate at which reactants turns to product. Either you say the rate at which the reactants is used up or the rate at which the product is formed. Okay, so now let's see this. The amount of substance can be concentration, can be mass, can be volume. So you can measure rate based on concentration, you can measure rate based on mass, you can also measure rate based on volume, but the units of their rates will vary. So if you use volume, concentration for example, the rate will be mole per dm cube per second. If you use mass, the unit will be grams per second. If you use volume, it will be centimeter cube per second. Let's see examples here quickly. Now this one says in the reaction 10 cm cube of the product was formed in 10 seconds. What is the rate of the reaction? In this case here we are given volume. Okay, so we can say our rate in this case here is volume all over time. Amount of substance in this case is volume. Okay, so which is 10 cm cube, okay, all over 18 seconds, and that should give us 0.56 cm cube per second. This is beautiful. Okay, so this is one way to determine rate. Now let's see another question here. It says the concentration of a substance in the reaction is 2 moles per dm cube at t equal to 2 seconds and 1.2 mole per dm cube at t equal to 5 seconds. What is the rate of the reaction? Now remember, we say rate is equal to the amount of substance, which you can also say change in concentration all over change in time in this case here, because the change in concentration here we can say 2 minus 1.2, okay, or you say 1.2. okay, let's do it this way. Sorry, it should be 1.2 minus 2. The rate here should have a minus sign here, so that would be minus 1.2 minus 2.0 divided by change in time here will be 5 minus 2. Okay, so this will now be minus 1.2 minus 2.0 should give us minus 0.8. okay, divided by 5 minus 2 is 3. So if you divide that now, you're going to get 0.27 approximately. Okay, so in this case here the unit will be mole per dm cube per seconds, because we are dealing with concentration here. Let's see one more question here. It says the mass of a product in a reaction increased from 2 grams to 5 grams in 10 seconds. What is the rate of reaction? Very simple. The rate of reaction will be change in mass all over time, okay? So in this case now, the change in mass is 5 minus 2, okay? Divided by time, which is 10. So that's going to give us 3 over 10, which is going to be equal to 0.3. Now, but I want to take notes, or you to take notes of something here. If you're dealing with the reactant side, then your rate will be minus delta M over T. But if you are dealing with product side, you can just say delta M over T. Okay, so the reactant side should have a minus sign because the concentration is reducing for the reactant, but for the product, the concentration is what? Increasing. Thank you very much. Have a nice day. See you in the next class.